Hey everyone, welcome to this video on networking interview questions and answers by Simplilearn. In this video, we will take you through the top 10 networking interview questions and answers that can help you crack your interview. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn.
Let's start off with question 1. What is the OSI model? Explain the different layers of the OSI model. OSI largely is a theoretical model utilized to understand networking and how data packets are created and how they are being processed by a computer. This is normally used by the TCP/IP, the Transmission Control Protocol over Internet Protocol software suite. So OSI is known as the Open Systems Interconnection Model. It is a reference model that describes how applications are going to interact via the computer network. There are 7 different layers that we need to understand. They are as follows. So in this diagram, there are these 7 different layers. We start up from the bottom. First is the physical layer, the data link layer, network layer, transport layer, session layer, presentation, and application. When such a question is asked in an interview, it is not only that we identify these 7 layers, explaining what the OSI model is in the first place. We then try to identify these 7 layers and we give a brief description about each and every layer. If there are any additional questions, they will come after this basic question. So let's start off with the physical layer. This is the lowest layer of the OSI model. Now this is where any and every physicality of your computer comes into the picture. So it could be a network interface card, it could be an RJ45 or a Cat5 cable, anything that allows data to be transmitted physically from your machine to another machine. Next comes the data link layer. So on the data link layer, as far as networking is concerned, we just need to understand that data packet is encoded, decoded into bits at this layer. This is also the layer that deals with MAC addressing. So the physical address of every network interface card, which is the MAC address, which is utilized to route data packets over the network. This is where the MAC address resides on the data link layer. The next layer is the network layer. Here datagrams are transferred from one to another. The function of this layer are routing and logical addressing. The moment we talk about routing and logical addressing, IP addresses come into the picture. IP version 4, IP version 6. So network layer will deal with IP addressing and the routing of those packets. Then comes the transport layer. This is the layer responsible for end-to-end connections. That automatically signifies that this is where TCP and UDP will be working. TCP stands for Transmission Control Protocol, UDP for User Datagram Protocol. TCP is a connection-oriented protocol, whereas UDP is a connection-less protocol. These two protocols are utilized to establish connectivity between two machines. TCP is a more reliable method of connectivity because there are a lot of packets that are sent across to verify that the data has been sent, data has been received, and so on and so forth. Whereas UDP is a connection-less protocol where data is just dumped without verifying whether the receiver actually receives that data or not. So in a nutshell, on the transport layer, TCP and UDP make their appearance, and this is where that functionality lies. Then comes the session layer. This controls signals between the computer. It establishes, maintains, and terminates connections between processes. So in the transport layer, we talked about TCP and UDP. UDP being a connection-less protocol where data is just transmitted without verifying whether the receiver received that data or not. Whereas TCP, we studied, is more of a reliable protocol. Thus, there are different packets, signals that will be sent across to verify that data has been transmitted, it has been received properly, and then the next segment of that data is being sent. So those control signals are established using the session layer. So the three-way handshake of TCP, the acknowledgement packets, and those kind of packets will be taken care of on the session layer of the OSI model. Then comes the presentation layer. The presentation layer is responsible to translate data into the application layer format. So the formatting, right? MIME or encoding that is being utilized, the UTF-8 character set that we utilize for presentation, encryption mechanisms, all of these work on the presentation layer. And finally comes the application layer, where the application itself uses a particular protocol. so that the other machine on the receiving end, the application on that machine will be able to understand what the communication was about, right? So in a nutshell, if I start from up top, the application layer will deal with any of the data that the application is generating. So maybe a user input, you're logging in, you're typing the username, password, all that data will be constructed, let's say, into an HTTP or an HTTPS format. That's where your application layer comes into the picture. Then the formatting of which into UTF-8 and the encryption of which would be done at the presentation layer. Then this transport layer and the session layer would kick in to establish a TCP session, do the three-way handshake, establish that connectivity. IP addressing would be done on the network layer, MAC addressing would be done on the data link layer, and when everything is ready on the physical layer, the packet will be sent out. At the receiving end, the packet will be received on the physical layer, and then all these layers will be reversed, and finally at the application layer, the data would be presented to the application, who would then execute it and showcase it on the screen of the recipient. So this is the way you want to explain this question. You want to be very concise, precise about what you're explaining. You don't want to go into too hypothetical scenarios. You don't want to dilly-dally with the layers. You just want to give the basic functionality, want to demonstrate that you understand what the OSI layer is, how the computer functions, and you want to move on from there. If the interviewer has any further follow-up questions, they will ask those specific questions. So that's question 1. Moving on to the question 2. Question 2 is define unicasting, multicasting, and broadcasting. Now this is a question which can be very lengthy, but again, most of your interview questions are designed that way. It's basically to understand how much conceptually you are aware about these technologies. So you have to be very concise. Don't go rattling about technology too much, but in a concise manner, just try to explain what these things is. So when data is being transmitted over a network, it can be transmitted either in one of these particular manners. It can either be a unicast, multicast, or a broadcast. So what is unicast? Unicast is when a message is sent from a single user to a single receiver. So one to one, right? So one machine talking to another machine and nobody else. So also known as point-to-point communications, one point to another point. If you have to send information to multiple receivers, then you will have to send it using multicast, right? So this is where your multicast networking comes into the picture. So in our case, let's assume it's a network where there's a class C network, approximately 255 odd machines. And within these, there are two machines that want to talk to each other. If they want to talk between each other, it would be a point-to-point communication where they will utilize unicast, where only these two machines will have visibility of that conversation and the other machines will not even realize that this conversation is taking place. If one machine wants to talk to multiple machines, then the multicast comes into the picture. As the name suggests, in this mode of communication, data is sent from one or more sources to multiple destinations. Multicast uses the Internet Group Management Protocol, also known as the IGMP protocol, to identify groups. So under this IGMP protocol, various groups are created where machines are subscribed to those particular groups. And whenever a message needs to be sent through those groups, it will be identified by the IGMP protocol, and then that particular message will be sent to those multiple machines that are members of those particular groups. And then comes the broadcast. The third method is known as the broadcast. As it says, it is going to broadcast to all. So this is one to all. That is communication between a single user, and it is going to be sent to all the machines in that particular network. Right? So the three ways: unicast is one to one, multicast is one to many, and broadcast is one to all. Then question number 3. What is DNS? DNS stands for Domain Name System. It is like the internet's phone book that is responsible for mapping the domain name into its corresponding IP address. And let me give you an example over here. Whenever we go and open up, let's say, a browser, a Google Chrome browser, we type in www.google.com and then we press enter, and magically Google comes in front of us, the website rather. Now, how does the computer know who Google is? Because as far as we are concerned, humans understand Google and words like that. Computers don't. Computers deal with binary, zeros and ones, right? And As far as internet is concerned, they will only deal with IP addresses and MAC addresses. So how does a computer know how to find google.com and where is it located? So the moment we type in the browser window, in the address bar, google.com and press enter, a DNS query is generated automatically by the browser, where a packet is sent to our DNS servers asking what the IP address is. So in short, DNS resolves domain names to their corresponding IP addresses. There is a DNS server which will have this index, a database of all the domains associated with their IP addresses. If one particular DNS server does not have that information that you're looking for, it may query another DNS server who may have that particular response. So the first thing is, when you type in domain name, it gets resolved with the DNS. It identifies the IP address corresponding to that particular domain name and thus allows the computer to route that packet to the particular server where that domain name resides. So in this scenario, if you look at the screen, on the local PC, you have typed in cybersecurity.com. There is a DNS resolution, that a query that goes to the DNS server. What is the IP of cybersecurity.com? The DNS server looks it up in its particular database. If it has the corresponding IP address, it will then respond back. The IP address is 172.17.252.1, after which the packet is sent off to cybersecurity.com. Moving on to question number 4. What is a firewall? Now, this is a very good question, and normally a very basic answer that I've ever heard is that a firewall is a hardware and a software firewall. But that's the functionality of a firewall. That is how you can install a firewall. But there are different types of firewalls, and there is a specific functionality that a firewall is created for, right? So a firewall is either a hardware or software, but its responsibility is for blocking either incoming or outgoing traffic from the internet to your computer. They secure a network. So essentially, the firewall will allow a connection to happen or disallow a connection to happen. It won't go beyond that. That's the basic functionality of a firewall. Okay, so based on the configurations that you have done, based on the rules that you have created on the firewall, it will then, based on those rules, identify whether some traffic is allowed in that network or some traffic is to be blocked from entering that network. So as the screen shows, the firewall rules will analyze whether the traffic is good. If yes, it will allow. If the traffic is bad, it will block the traffic and not allow that connection from happening in the first place. Now, there are a few common types of firewalls that also need to be included in the answer to this question. And the first one is a packet filtering firewall. These are the most common types that you will come across, which analyze packets and lets them pass through only if they match an established security rule set. Now here people do get confused when we say that we analyze packets. People think that these firewalls will analyze the contents of that packet, which is not correct. When a definition for a packet filtering firewall says that these firewalls analyze packets, it means that they are only analyzing the source and destination IP addresses, port numbers, and the protocols that are mentioned in those packets. These firewalls do not have the capability of deep packet inspection, or DPI as it is known. If that capability comes into the picture, you're basically looking at an intrusion detection system or an intrusion prevention system in today's world called as a next-gen firewall. Okay, so a packet filtering firewall essentially will only analyze data packets for its source and destination IP addresses, port numbers, and the protocol that is being utilized. It will then map that information to the rules that are there on the firewall. And based on those rules, it will either allow that connection to happen or disallow that connection from happening. The second type is a proxy firewall. These firewalls filter network traffic at the application level. So when you say application level, they work at the layer 7 of the OSI model. Packet filtering firewalls, since we have mentioned that they worked on IP addressing and port numbers, will work on the network layer of the OSI model. Also on the transport layer, because they also look at protocols. Proxy firewalls will work at layer 7, which is the application layer of the OSI model, and will deal with application level protocols such as HTTP, HTTPS, FTP, SMTP, and so on and so forth. And the third one is a stateful multi-layer inspection firewall. These filter packets at the network, transport, and application layers. So they basically do the job of the first and the second type of firewalls. The packets are compared to known trusted packets. But now the first question is, if there is a stateful multi-layer inspection firewall, why do we have type 1 and type 2 firewalls like packet filtering and proxy firewalls? That is because that is how the firewalls have evolved. We started off with the packet filtering, then we added functionality to it, and so on and so forth. So if a question comes, what is a firewall? You start off with the option saying it is a hardware or software. This is the responsibility, the functionality of a firewall is to allow good traffic and disallow bad traffic based on the rules that have been configured on the firewall. And then you've got basically 3 types of firewalls: packet filtering, proxy, and stateful multi-layer. And just include a brief description of each of these firewalls.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Then moving on to question number 5. What is a VPN? VPN is also called a virtual private network. It is a connection between a VPN server and a VPN client. So it basically creates an encrypted tunnel between the client and the VPN server, which is then utilized to secure the connections that you're making with the internet. So as you can see in the diagram, the user has a VPN client installed on their machine. The VPN client then creates an encrypted tunnel to the VPN server. And through this tunnel, encrypted data is transmitted, which can then be processed by the VPN server, sent to the internet. Information can be received back by the VPN server. The VPN server will encrypt that data back and send it back to the user. So if there is a man-in-the-middle attack that is happening, or a hacker trying to eavesdrop on the communication mechanism, they will not be able to do so because of the encrypted tunnel. It is very difficult to decrypt this or hack through this encrypted tunnel. It is possible, but it is very difficult to achieve that. Moving on to question number 6. What are the advantages of distributed processing? Now, before we go into advantages of distributed processing, we first have to understand what is distributed processing. So it is a term which describes various computer systems that use more than one processor to run an application. Here, multiple computers across different locations share the same processor. The advantages of distributing processors are as follows. But before we go into the advantages, distributed computing is basically where multiple machines will pool their resources together to run a singular application. So an application that has multiple resources and can scale up and scale down as and when required. The advantages are that it can be very useful in data recovery. For example, RAID, where you're striping data on various hard disks. It is reliable. It is cheaper. Lower cost can be achieved. And it is easy to expand because of the scalability factor that we just talked about. If there is loss of data in one computer, it can then be recovered by another interconnected computer. And one of the examples would be blockchain in today's world, right? What is blockchain? That this data is created live and stored on a connection of computers. So if one of the computers goes offline, the other computers in that network will still have that data, and the blockchain will still function without any issues. The second point, a glitch in one machine does not affect the processing, as there will be multiple other machines like we discussed in the blockchain. Several cost-effective mini computers are used instead of costlier mainframe machines. So instead of having a server bank, I can have multiple machines interconnected together, and they can function in that particular blockchain or for that particular distributed processing mechanism. Depending on the amount of data processing, more computers can be attached to the network. Thus, you can increase the number of computers that can be a part of that blockchain, or you can reduce them as and when necessary. Moving on to question number 7. What is TCP/IP? TCP/IP, or Transmission Control Protocol over Internet Protocol, is a set of communication protocols that are used to interconnect networking devices on the internet. This protocol defines how data should be transmitted over the internet by providing end-to-end communications. So essentially, if you want networking to be established on your machine, you will need TCP/IP. Without TCP/IP, there will be no workgroups, there will be no domains. Basically, your interconnectivity will go for a toss. TCP/IP is a software that once installed on your machine will then interact with the hardware, which is your network interface cards, and then your switches, wires, cables, and all those, through protocols that have been already pre-configured in it. So within the TCP/IP suite of softwares, you will have all the protocols, all the functionality of the OSI layer, and each and every protocol that works on each and every layer will be predefined and pre-configured to work in a particular manner. The internet protocol is all about routing each individual packet to make sure it reaches its destination. So with the TCP, you're talking about the protocols that will allow you to format the data and generate it so that you can communicate it over the network. The IP will then deal with the routing of those packets so that the packet can be routed to the correct computer and be received by the recipient. So the TCP IP model is the compressed version of the OSI model. The 7 layers will get converted into 4 layers: the network access layer, internet layer, transport layer, and application layer. Going on to question 8. What do you mean by ipconfig and ifconfig? Both of these are commands, the first one on a Windows machine, the second one on a Linux machine. So ipconfig is known as the Internet Protocol Configuration. This is a command that is used on the command line interface of Microsoft Windows to view all the adapters and the configuration of each and every adapters for their network interfaces. So as you can see on the right hand side in the command prompt screen, if once you type in the ipconfig command on the C prompt and press enter, it will give you a list of all the adapters that are there. So you can see wireless LAN adapter, local area connection, the media is disconnected, it doesn't exist. At the bottom you'll see the Wi-Fi connection, wireless LAN adapter, and it can give you the IP version 6 IP address, IP version 4 address, the subnet mask, and the default gateway. So this is the configuration that allows the machine to know on what network it is on, what is the default gateway for communicating to the internet, what is the subnet mask, so how many computers may exist in that particular network, and what is the IP address of that specific computer so that it can communicate across the network as well. ifconfig is the same thing on a Linux, Mac, or Unix operating system. So the command will also give you the list of interfaces and the configuration of each and every interface. It is used to configure, control the TCP/IP network interface parameters from the command line interface. It allows you to see the IP address of these network interfaces. So here you can see the WLP19S, the IP address being 192.168.43.215, subnet mask being 255.255.255.0, with the broadcast being 192.168.43.255. Question 9. What is the difference between a domain and a workgroup? This can be a very interesting question and can be a very lengthy question at the same time. A workgroup is nothing but a decentralized network where you have interconnected multiple machines together and each machine acts in its own individual capacity. Thinks of itself as a server, right? So a decentralized network, every user manages the resources individually on their PC. So local users on their own PCs managing the network shares, what can be shared from that particular machine, what data should be shared, should not be shared, to whom it can be shared with, and so on and so forth. It is good if you've got a small network, a few machines altogether, and you want them to interact with minimal management effort, right? So each user will decide what they want to allow other users to see on that particular network. And all of them would be connected over a LAN, a local area network, either a wireless or a wired one. So if you look at your home Wi-Fi right now, that is one of the best examples of having a workgroup. The domain, on the other hand, is a centralized network model. So in a corporate environment, whenever you go there and you got a domain-based username and password, which when entered onto a particular machine gives you access to the entire network or whatever applications and whatever resources have been allocated to you, that is where the domain comes in. So it also uses a single sign-on mechanism for all the resources that are to be made available to you. Whereas in a workgroup, you're a local user only meant for that particular computer, right? So coming back to the domain, it is an administrator who's going to manage the entire domain and all of the resources connected to the domain. The resources could be switches, routers, servers, data stores, applications, web servers, mail exchange servers, and so on and so forth. So all of these are administered by an administrator through the domain. It is the most reliable and the optimum solution for a large network where multiple users are going to interconnect and share that data amongst each other, right? The computer can be connected to any network. That means you can be on the internet, and through the internet using a VPN, you can connect to your corporate network, authenticate in, and get access to whatever resources you are allowed to access. Whereas in a work group, you have to be a part of that network to access that particular network. If you change your location, you go and connect to another Wi-Fi, you will lose access to your previous Wi-Fi. Then the last question for the networking section: what is data encapsulation in networking? Data encapsulation refers to the process of adding headers and trailers to the data. The data link layer binds each packet into a frame that contains the hardware address of the source and the destination computer. So in this example, when we are talking about data encapsulation, we have talked about how data that has been created by the application layer would have a header and a trailer that will give the various informations of where that data needs to be sent. So the hardware address, which is the MAC address, comes into the picture and gets added to the header, and the IP addresses, port numbers, and all of those things would then be added to this trailers as well, so that the data can be then routed to the intended recipient of that particular communication.
And with that, we have come to the end of this video on networking interview questions and answers. I hope it was informative and interesting. If you have any questions related to the topics that were covered in this video, please ask away in the comment section below. Our team will help you solve your queries. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.